For 4.3, to continue on looking at some of the application problems that are on there. Now there's a couple more challenging ones. We're going to look at some of the basic stuff for the moment, once that focuses. For this one, a biologist wants to know the width of a river in order to properly set his instruments for studying the pollutants in the water. From point A, the biologist walks downstream 70 feet to point C. From this sighting, it is determined that the angle is 54 degrees. How wide is the river? Okay. Actually, this is standard procedure for figuring out how far it is across the river. You spot an object that's directly across at a 90-degree angle, walk down a bit, spot it, use a compass, and figure out what angle you're at to get to the same object, and you can tell how far that is away. Okay. The nice thing about this is it makes what kind of triangle?
Right triangle.
Right triangle. Now I'm trying to figure out this side here. So if I try to figure out that, they use a W for width there. Which trig ratio would I use? Tangent. So tangent of that 54 degrees is going to be equal to what over what? Yeah, they use a W, but yeah, W over X, whatever, over 70. So then how would you solve for W? Multiply by 70. What do you get? $96. And honestly, since we're talking about just feet across the river, 96.4 is probably sufficient, unless you're building a bridge or something. Not too bad. In this first section of with these word problems, they will stick to pretty much things like this. When we get back into the law of sines, law of cosines, those will get harder. Okay. What about this one? Here they're still giving you a little bit of information in the diagram, but not as much. 12-meter flagpole casts a 12-meter shadow. Find theta. Well, where's the angle of elevation, first off? Yeah, they give it to you as theta there. What if I ask for an angle of depression instead? Where would that be? Top of the flagpole, like here? It's opposite, it's over here?
Oh, no, on the other side. It's like above the hypotenuse?
Yeah. The idea, it's always down from the horizontal or up from the horizontal. So if I was looking for angle of depression, that would be up here. Angle of elevation, down here. What are those two things compared to each other? What are they going to be? They will be the same. How do I know they're the same?
Because it makes you make it a rectangle, so it's a 90 degree angle. So you know that. Going
Two parallel lines are intersecting? What? You have two parallel lines and you have a transversal, the line crossing them both. Not corresponding. It's a couple words for it. Something angles.
inner.
Opposite interior.
Yeah, alternate interior, but yeah. Alternate interior angles. They are on alternate sides of the transversal and they're interior to the two parallels. Reaching back to geometry here a bit. Okay? But they're alternate interior, so that's why they're the same. Now in this problem, where would I put the 12 meters for the flagpole at? On the vertical? Where's the shadow at?
It's that bottom line.
Yeah. Thing is, do not confuse shade and shadow. I will have students that inevitably do this, where usually not talking about a flagpole where the shadow is really skinny, but shade from a building, things like that. I'll have students that will, on tests and things along those lines, will label this line as the shadow because it's in the shade. The shadow is the actual along the ground every time. Okay? Without bothering with SOHCAHTOA, what's theta? 45 degrees. Okay? Let's do one more. A ramp is 17.5 feet in length. Rises to a loading platform that's 3.5 feet off the ground. Find the angle theta the ramp makes with the ground. Where's 17.5 go? The bottom? The top? Why is the top? Yeah, the ramp is the hypotenuse. So 17.5 goes here. It's another one that students will screw up. Where's the 3.5 go? The vertical. So 3.5, and where's theta go? Yeah, in the bottom left corner here is your theta. It's where the ramp and the ground meet. So which trig ratio would I need to use to find theta? Sine, because you're given opposite and hypotenuse. So sine of theta is equal to opposite over hypotenuse. Then what? Inverse sine. So inverse sine on your calculator of that 3.5 over 17.5 gives you what? Say again? 18.4? Not even close. 11.5 degrees. Questions on any of it? That's it.